Okay, so this is the final video of this series. Up to this point, we've talked about how to find the areas of rectangles, of squares, of parallelograms, and of triangles. Now we are going to focus our attention on rhombuses. So for this one, I actually want to show you the theorem first, and then we'll go through and we'll talk about why it works. So for a rhombus, to find the area, or one way that you can find the area, is to find the product of the diagonals. Now you can always, as long as you have enough information to do it, apply the area equals base times height formula because a rhombus is a parallelogram. But this one also works for rhombuses and can come in handy as kind of a quick time saver. So let's prove this here. So again, the area of a rhombus equals half the product of its diagonals. So let's check this out. I'm going to draw or do the best drawing of a rhombus that I can produce here. And what I'm going to do is I'm going to label the vertices just so it makes it a little bit easier for us to talk about the diagram. All right, what I'm going to do here is I'm going to draw in the diagonals. So I'm going to draw the diagonal from A to C. And what I'm going to do is I'm going to let AC equal D1, just like we see down in the formula below. And then I'm going to draw in a second diagonal. So B to D, okay. And we're going to let BD be diagonal number 2. All right. Now there's a couple properties that you need to understand here. One is that the diagonals of a rhombus are perpendicular, and that they bisect each other. So that's congruent, and that's congruent right there. So far, so good. All right, so what that means, I'm going to draw in this point in the middle and call that point E. We know that AE is 1/2 diagonal number 1, which is AC. Yes, we also know that CE is also 1/2 diagonal number 1. Now, the other thing that we know is that these two triangles, triangle ABD, is going to be congruent to triangle BCD, which also means that they have the exact same area. So, how do I find the area of, say, one of those triangles? Let's find the area of triangle ABD. So the area of triangle ABD is going to equal 1/2 the base times the height. Well, in this case, the base is, I'm going to use the highlighter here, the base is BD. Now remember, we let BD equal D2. The height is AE, which is 1/2 diagonal number 1. So we're going to have 1/2 times 1/2 D1 times D2. So that's the area of triangle ABD. So that's going to be 1/4 D1 times D2. Now that's the area of this triangle that I'm coloring in purple. Now the triangle that's adjacent to that, which I'm going to color in green, is congruent to that triangle. So it also has the same area. So I can multiply that by 2, and that's going to give me the entire area of the rhombus. So we're going to multiply by 2, and that gives us 1/2 D1 D2. So that's where that formula is coming from. So the area of the rhombus is going to be 1/2 D1 D2. Now let's go down here and apply that. I'm just going to look at example 3 because example 4 is just, it's not a rhombus, it's just a parallelogram. So we're just going to focus on example number 3. So based off of what I'm given here, I know that this is a rhombus. And what I also know is that the diagonals are perpendicular. So this right here is a right triangle. And those sides form a Pythagorean triple. So that means that this portion of this entire diagonal that I'm highlighting in green is 3. So one diagonal has to be 6 unit because this is also 3. Now the second diagonal, again, that part has to be 4, so diagonal 2 has to be 8. So the whole area for this is 1/2 D1, D2. So 1/2 D1 is 6, D2 is 8. So this will end up being 48 divided by 2, which is 24 units squared. Okay, and that's a shortcut if you know the lengths or if you can find the lengths of the diagonals to help you find the area of a rhombus. It's just 1/2 D1 times D2. Okay, that'll do it for this series of videos. Again, I hope, as always, that this was helpful. Feel free to contact me with questions or concerns, and we'll see you in the next video.